Imagine gazing up at the night sky, that vast canvas of twinkling stars in endless black, and realizing that right now as we speak, a visitor from another star system is hurtling through our cosmic neighborhood. It's not a probe from a sci-fi movie. It's real. Discovered just months ago on July 1st, 2025, by the sharp-eyed Atlas telescope in Chile, this interstellar comet, named 3I/ATLAS, is the third confirmed wanderer from beyond our solar system. But unlike its predecessors, it's rewriting the rules of what we thought we knew about the universe's building blocks. Why does it matter? Because 3I/ATLAS isn't just a frozen relic. It's a time capsule, billions of years old, carrying secrets from a distant stellar nursery that could unlock how planets like Earth form and whether life elsewhere follows the same recipe. Picture this: a chunk of ice and rock racing at over 130,000 miles per hour, its surface cracking under the sun's heat, spewing gases that tell tales of alien worlds. In the next 20 minutes, we'll dive deep into its discovery, its bizarre chemistry revealed by NASA's James Webb Space Telescope, and what it means for space exploration. Stick around, because if this comet is a messenger, its message might just change how you see the stars forever. Let's start at the beginning, shall we? The story of 3I/ATLAS begins in the chilly heights of Rio Hurtado, Chile, where the ATLAS, Asteroid Terrestrial Impact Last Alert System, scans the skies for potential threats from space. On that fateful July morning, it spotted a faint streak, a fast-moving dot defying the gentle curves of solar system orbits. At first glance, it looked like any other comet, a dirty snowball tumbling through the void. But astronomers quickly crunched the numbers. Its path? Hyperbolic, with an eccentricity of 6.1, the highest ever recorded for a natural object in our solar system. That's code for interstellar. It's not bound to our sun. It's slingshotting through on a one-way ticket, entering from the direction of Sagittarius, the Archer constellation, and destined to exit forever after brushing past the sun. This wasn't the first such visitor. Rewind to 2017, Oumuamua, the cigar-shaped enigma that sparked endless debates about alien tech, though science settled on a natural, if weird, explanation. Then 2019 brought 2I/Borisov, a more traditional comet with a visible tail. But 3I/ATLAS, it's different from the jump. Pre-discovery images from Atlas telescopes worldwide and the Zwicky Transient Facility pushed its sighting back to June 14th, 2025. By July 2nd, observatories from Lowell in Arizona to Mauna Kea in Hawaii confirmed a faint coma, a hazy envelope of gas and dust, and a tail stretching 3 arc-seconds. Boom. Comet status granted, designation C/2025 N1. Atlas. Yet its speed, 137,000 miles per hour and climbing, sealed the deal. This thing had journeyed from the Milky Way's thick disk, a region of ancient stars 7.6 to 14 billion years old, predating our own solar system by eons. What makes this discovery so thrilling? It's a snapshot of the cosmos's recycling bin. Interstellar objects like this are ejected from their home systems during chaotic youth. Think gravitational tug-of-wars between young planets and stars. And with estimates suggesting thousands zip through our solar system yearly, 3I/ATLAS is our best shot yet to study one up close. No spacecraft chase needed, it's coming to us. As it hurtles inward, ground-based scopes like the Very Large Telescope in Chile and space assets like Hubble have painted a portrait, a nucleus between 1,444 feet and 3.5 miles across, wrapped in a developing coma that's already glowing green under certain filters. Fun fact, during a lunar eclipse on September 15th, 2025, astrophotographer Chris Shore captured it shimmering emerald against the shadowed moon, a poetic nod to its icy heart awakening. But here's where the plot thickens. As 3I/ATLAS closed in, crossing Jupiter's orbit at 4.5 astronomical units from the sun, the real detective work kicked off. Telescopes worldwide pivoted, hungry for data. Hubble snapped its clearest portrait on July 21, 2025, from 277 million miles away, revealing a fuzzy blur against streaking stars, proof of its blistering pace. The European Southern Observatory's Very Large Telescope joined in, detecting nickel emissions but no iron, a puzzle hinting at exotic formation processes. Why nickel without its metallic buddy? Perhaps vaporized in a stellar wind from its birth star, or cooked in a protoplanetary disk unlike anything in our system? These early glimpses built hype, but they were just the appetizer. The main course? Enter the James Webb Space Telescope, humanity's infrared oracle, peering deeper than ever before. Transitioning from these initial sightings, let's zoom into the heart of the mystery: JWST's groundbreaking observations. On August 6, 2025, Webb's Near-Infrared Spectrograph, or NIRSPEC, locked onto 3I/ATLAS, dissecting its light like a cosmic chemist. What poured out? A revelation in gases. This comet isn't your average water-ice wanderer. Its coma, that glowing halo, is dominated by carbon dioxide, CO2, at an astonishing ratio of 8:1 to water ice. That's the highest ever recorded in any comet, solar system native or not. Imagine a cosmic snow cone, but instead of fluffy H2O, it's packed with dry ice, sublimating into fog under solar heat. Webb also spotted carbon monoxide, CO, and hints of complex organics, molecules that could be precursors to life. Why is this a game changer? Comets are the solar system's time capsules, preserving ices from formation 4.6 billion years ago. Our local ones, like those in the Oort cloud, show water-heavy profiles, reflecting a wet, temperate birthplace. But 3I/ATLAS, its CO2 dominance suggests a colder, drier origin, perhaps around a red dwarf star in the galaxy's thick disk, where temperatures plummeted to -400 degrees Fahrenheit. A preprint from the team, led by Martin Cordner of Catholic University of America, dropped online in August 2025, calling it a frozen relic that challenges models of planet formation. Could this explain why some exoplanets are rocky deserts while others are watery oceans? Absolutely. And the asymmetry in its coma, richer in gas on one side, hints at uneven heating or spin, adding layers to its story. Let's break down the chemistry a bit because the numbers are mind-blowing. In solar system comets, water typically makes up 70 to 90% of volatiles. Here, CO2 steals the show at over 50%, with water a mere sidekick. Bullet point the key detections: carbon dioxide, CO2, dominant gas, ratio 8:1 to H2O, unprecedented, implying formation in a low-temperature environment below 100 Kelvin. Dash carbon monoxide, CO, present in trace amounts, suggesting outgassing from deeper layers as the comet warms. Nickel emissions, detected by VLT, no iron counterpart, possible from vaporized surface alloys, a first for interstellar objects. Organics, subtle signatures of hydrocarbons echoing Oumuamua's weirdness, but more comet-like. These aren't random, they're clues. Compare to Borisov, which had more balanced ices, or Oumuamua's dryness. 3I/ATLAS bridges them, a hybrid hinting at diverse interstellar chemistry. As it speeds toward perihelion, its sun-kiss on October 29, 2025, at 1.356 astronomical units, expect more outbursts. Already by September 4th, Gemini South captured a crisp image showing its tail lengthening, colors shifting through filters. This data isn't just trivia, it's fuel for simulations. Teams at Georgia Tech and Michigan State are modeling how such a CO2-rich body forms, predicting it ejects from systems with giant planet migrations, echoing our own Jupiter's youth. Now, as 3I/ATLAS barrels toward the inner solar system, one of the most exciting chapters unfolds: its close encounter with Mars. On October 3, 2025, at 4 UTC, it zipped within 18 million miles of the red planet, closer than to Earth at any point. Why Mars? Its orbit aligned perfectly, turning our neighbor into the VIP viewing platform, and Europe's space assets were ready, ESA's ExoMars Trace Gas Orbiter, TGO, and Mars Express swung their instruments, capturing the comet as a fuzzy white dot against the Martian horizon. TGO's Nomad spectrometer sniffed the coma from afar, confirming the CO2 fog, while Mars Express's VMC camera snapped visuals of the tail against the rusty landscape. This wasn't just a flyby, it was a symphony of observation. From October 1st to 7th, both orbiters multitasked, studying Phobos 1 minute, then pivoting to our guest. The images, stunning. The comet's coma, that envelope of sublimating ices, appeared elongated, trailing dust particles that might one day pepper Mars's thin atmosphere. No impact risk, of course, too distant. But the data? Gold. It lets us test how interstellar material interacts with planetary environments. Imagine if a fragment skimmed Europa or Enceladus. Could it seed oceans with alien organics? Fun analogy. It's like hosting a foreign diplomat at a family dinner. Awkward, brief, but the stories exchanged linger. Historical echo here. Remember when Borisov photobombed Hubble? Or Oumuamua's silent sail-by? This Mars rendezvous ups the ante, blending planetary science with interstellar sleuthing. ESA's Colin Frank Wilson, project scientist, noted the unique opportunity to observe from 29 million kilometers away, far better than Earth's vantage. And looking ahead, NASA's Juno, orbiting Jupiter, gets a front-row seat in November 2025, post-perihelion, when the comet's boiled-off CO2 reveals its stripped core. Perseverance rover might even glimpse it in the Martian sky. Did it? Rumors swirl, but confirmation awaits. These moments remind us, space exploration isn't solitary. It's a global relay, passing the baton from Earth scopes to Mars machines, chasing one comet across 500 million miles. But 3I/ATLAS isn't done dazzling yet. As it nears the sun, its activity ramps up, outbursts of gas and dust turning it into a blazing beacon. Predictions? Brightness peaking at magnitude 10 to 11, visible to amateur scopes in Virgo and Leo by December 2025, though dimming post-perihelion. Webb plans a December revisit, piercing the coma to size the nucleus precisely, maybe using MIRI for thermal mapping. SphereX, NASA's all-sky infrared surveyor, already contributed early data, confirming the thin disk origins and high vertical velocity, tilting its path through the galaxy like a skipped stone on a pond. Comparisons sharpen the intrigue. Versus Earth comets, more CO2, less water, colder birth. Versus Borisov, similar but drier, no fragmentation yet. Versus Oumuamua, active, not inert, debunking artificial hype. Data breakdowns show its velocity, inbound 61 kilometers per second, outbound faster, slingshot effect boosting it to escape velocity. Orbital mechanics confirm no return. It'll fade into the thick disk, perhaps visiting another system in a million years. Fun fact, at its age, 3I/ATLAS predates the Sun by twice over, a fossil from the galaxy's toddler phase, when thick disk stars forged heavy elements in furious supernovae. Theoretical whispers add spice, backed by evidence. Could it harbor prebiotic molecules? JWST's organics suggest yes. Carbon chains akin to amino acid building blocks. A July 2025 Archive paper by Astor Taylor and Daryl Seligman posits implications for early planet formation. CO2-rich comets might deliver volatiles to rocky worlds, kickstarting atmospheres. No speculation here, just models fitting the spectra. And diversity? Interstellar objects vary wildly, implying a zoo of planetary systems out there. One study estimates one such visitor inside Pluto's orbit yearly. We're just getting better at spotting them. As 3I/ATLAS arcs away, post-perihelion in late 2025, its legacy crystallizes. We've glimpsed a blueprint from another star, a CO2-shrouded comet, ancient and aloof, challenging our assumptions. Key takeaways? First, interstellar chemistry is weirder than imagined. CO2 dominance hints at cold, metal-poor nurseries shaping unique worlds. Second, observation networks, from ATLAS alerts to JWST deep dives, prove humanity's reach. turning fleeting visits into treasure troves. Third, it underscores urgency. With thousands inbound, future missions like ESA's Comet Interceptor, launched 2029, could rendezvous, scooping samples mid-flight. But let's ponder deeper. What if 3I/ATLAS carried a molecule that sparked life's spark here eons ago? Or signals a galaxy teeming with icy nomads seeding habitability? Are we alone, or just late to the cosmic party? These questions linger like comet tails, fading but unforgettable. For space enthusiasts, beginners dipping toes into astronomy, or experts tweaking models, this story invites all. What strikes you most? The alien ices, the Mars flyby, or the tech unveiling it? If this journey through the stars ignited your wonder, hit that like button. It fuels more deep dives. Subscribe for updates on 3I/ATLAS's outbound trail and beyond. Black holes, Mars missions, exoplanet hunts. Comment below. Would you chase an interstellar comet with a spacecraft? Or is studying from afar enough? Check our playlist on recent space discoveries for more. Thanks for exploring with me. Until next time, keep looking up. The universe is calling.